In the next several minutes, I'm going to tell you how decentralized identities are actually enabling an entirely new web architecture. Let's get into it. In a previous video, I already explained this high-level architecture of the decentralized identity ecosystem. We've got decentralized identifiers that point to a DID subject, a person like myself. This DID also points to a DID document, which is stored in a decentralized database called a verifiable data registry. But we're missing one component here. The problem is that when you create a private and public key, a DID wallet, it's just stored on your device. And there's no really good way of interacting with other DIDs. How do we set up messaging channels with other DIDs? How do we allow applications to connect and talk with our DIDs? We need some sort of cloud worker or node service in order to relay messages and store our data for public consumption. And this is where a decentralized web node comes in. This is what is enabling an entirely new web architecture right now. Currently, we have user clients, which are browsers, that talk to application servers. And this is how we get application data to be centralized on these servers. This is problematic for all the reasons I've specified in previous videos. But DIDs, the ability for a person to be able to control their identity, combining that with a decentralized web node, which is kind of like a personalized web service, like a personalized cloud drive, you should think of it as. Because now I'm going to be able to store my application data on my personal cloud drive, as opposed to siloed in individual centralized application servers. This is a massive unlock. So let me give you a practical use case of what this might look like. VCs, as I said before, verifiable credentials are going to be stored in your DID wallet. And so this is stored locally on a user's device, like a smartphone or a laptop. However, if we want anybody to be able to come in and publicly verify a specific VC of mine, then what I can do is I can publicly expose it on my decentralized web node, and then other entities can come in and verify that. So let's look at a specific example. Alice wants to apply to a bank. She wants to create a bank account, and we want to make sure that this bank is legit and that it has a government charter before we go ahead and open that account. So the charter, the bank's charter, the bank uploads that to its decentralized web node. It exists as a verifiable credential on the decentralized web node. And what Alice does is Alice has the DID of the bank, so it queries the verifiable registry with the bank's DID. It gets the bank's DID document back. And we know that the DID document has the bank's public key, some verification methods, and also the service endpoint. And the service endpoint will probably look similar to a URL. It's going to point us to the bank's decentralized web node. It's going to allow us to start to communicate with that web node and query the web node for the bank's charter. So we can query the decentralized web node and we can get a VC in return. And then our DID wallet verifies that VC using the bank's public key, and then whoever issued that bank the charter, presumably the government, we would then also verify the government's digital signature, who is the issuer of that bank charter. So this is one way how a decentralized web node allows us to create like publicly verifiable credentials. But there are many other very interesting use cases that I'll go through quickly with you right now. We can set up peer-to-peer encrypted messaging channels using people's DWNs. So Alice wants to message Bob, and what she does is she gets Bob's DID document from the verifiable registry. She finds Bob's service endpoint and then encrypts a message with Bob's public key and sends that encrypted message to Bob's DWN. Bob's DWN relays that message down to Bob's device, like a smartphone, and Bob can decrypt that message with his DID's private key. And the same can be done in reverse if Bob wants to reply to Alice. This is a beautiful architecture for a peer-to-peer messaging app, and it will cut out all centralized intermediaries from the ability for people to establish encrypted messaging channels with each other. We will also use these decentralized web nodes as application data stores. So in the Web 2 case, our application data is stored on web application servers, but in this Web 3 case, we're going to custody our application data. We are going to store that and can expose that however we want on our web node. So we can, like for the music use case right here, we create a music playlist on Groove, and that playlist data gets written to our decentralized web node. And if we go over to another music application, we have the ability to share that data with Tidal. But we own this data because Tidal is going to have to request permission to access it. So it's going to have to request permission to access it, and then we can grant Tidal that access. But this starts to open up what is called user-controlled data, and it also opens up interoperable application data. We can now create application data on one application and then bring it into all these other sorts of applications. The same is true for something like a travel plan. Right now, there are many different service providers, different web apps that you have to get on in order to schedule a trip. You've got to go to American Airlines or kayak.com and schedule your plane. You've got your car rental, that's a whole other service there. And then you also have your hotel reservation or Airbnb. So this trip planning takes place across 3 different services, and none of those services can talk to each other at this point. But instead what we can do is we can publicly expose or just expose the trip data to these 3 services, so they're all looking at the same source of truth. And then let's say that my flight gets delayed by 12 hours or 24 hours, then these applications can intelligently work around that information. Now my hotel and car rental can change my bookings a day later if my flight gets delayed by 1 day.